Cool. All right, let's get started. Thank you guys for being here again. Few updates on our expectations. I'm going to try to tackle any like BigBird questions first, and then once we're kind of clear of BigBird, then we can talk about whatever NLP or BERT related. And then I actually created a separate doc this time for our Q&A discussion. Excuse me. This research group minutes document is kind of read-only, but I enabled commenting on this one so people can kind of chime in a little bit more during the discussion. And then since the discussion topics are all over the place, I thought it made sense too to kind of like keep them out of the BigBird Research journal. Yeah, and then it took me, I kind of procrastinated last week, sorry, on getting the video up and sending that out. So this week I'm going to try editing and uploading the video immediately after the meeting. So it's, it's there while it's still fresh for everyone. I also created the forum post ahead of time, so that's in place. Yeah, and then I think I'll try to preserve the chat. Last week I kind of lost the chat, wanted to go back and read through it, but didn't have it. Yeah, and then the Q&A feature that we used last week seemed a little unnecessary. It seemed like the chat was manageable enough, so don't worry about using that. We can just use the chat feature, and Nick will monitor that. And then, yeah, we're also going to add a checkbox to the registration, so you guys don't have to re-register every week if you don't want to. You can just we can keep you registered and just automatically send you the invite every week if you're interested. So, yeah, so this week I've been working on using multiple GPUs with BERT. I did some research too into BigBird as well, but I thought I'd focus on the GPU stuff here, and then I think next week I'll go back to talking about BigBird architecture. So yeah, a couple things I was going to share about my experience using Lambda Labs, and then also how to modify your transformers code to use multiple GPUs. So yeah, so last week, John Dagdalen suggested using Lambda Labs potentially over AWS. He was saying it could be a good option if you're in the middle range of wanting just kind of a multi-GPU server. So I tried that out, and it was much easier to get going than it is with AWS. AWS is like this really big, rich ecosystem that is kind of overcomplicated for what we're trying to do here. So let's see, So Lambda, let's go to the website. I'll just start there. Yeah, so they kind of got their start creating like these GPU workstations and GPU servers, and then at some point they created this GPU cloud. And yep, they've got this nice clean dashboard. Signing up for Lambda was really easy. It was just like giving them credit card and email and name. So really quick. And then yeah, launching instances is super simple. Show you guys one here. So here's what they've got. When I first signed in, they said that all of these RTX 6000 type instances were at capacity, and that they're working on adding more. But so since I signed up, I've never been able to launch one of these. I'll try again here. Yeah, failed to launch instance. So I think those are still at capacity. So what I've had to work with is these two guys here, the 4X GTX 1080 Ti, and then the 8X Tesla V100. So this one's nice because it's dirt cheap, but I had some problems with it that I'll show you guys. And then this one, worked well for me, but is obviously quite expensive. But let me launch this one just to show you guys what this is like. So it takes a couple minutes to boot, and then they've got this really nice interface for kind of connecting to the instance through your browser. Makes it really easy to work in like a Jupyter notebook, for instance. Then their usage is nice and simple. Just got this little table showing me kind of what I've used so far. Racked up $8 in charges. Yeah, this is a little painful. The V100, it's like half hour, $5.50. So that might be another minute. Let me see if I've got anything else I can share while we're waiting on that. Yeah, here's a little sneak peek at the web interface. They let you launch either a notebook or a console or even just a terminal on the instance. There we go. So once it's running, they just have this Cloud IDE option. Hit launch, and that brings you to this this browser interface that we were just looking at. So create a new notebook. You can see, I know this won't show up on the presentation, but you can like drag and drop a notebook to upload it. Yeah, so pretty close to working on Google Colab. I feel like it's pretty straightforward. The one bummer is that these legacy instances, the 1080 Ti ones, for some reason I had trouble getting transformers to install. So let me try that again here, and we'll see. Sudo pip install transformers. Going well. Yeah. And I hit this guy. So it's trying to build, let's see, yeah, here we go. It's trying to compile this, python.h, no such file or directory. So I looked that up. In order to fix that, you need to install, there's like a Python 3 dev package. Let's see, how do I get back to, maybe this guy? I want to launch something different. There we go, terminal. Sudo. Something like this, but this didn't work for me either. Python 3 dev. I'm a bit of a Linux noob, so I only like halfway know what I'm doing here. So apt install Python 3 dev. Oh, maybe it's working this time. Last time I tried doing that from within the notebook. Maybe that was my issue. This is looking promising. Doesn't take forever to install. All right, let's see. Oh, good, done. So over here, I'm gonna close. Let's see, what can I do? I'm gonna restart this. Yeah. I restart it to make sure I get that, pick up that new package. And let's try this again. Nice. Looks like it got past it this time. That's really cool. I was hoping to ask you guys for your help debugging that, but it looks like we've got it. So that was transformers, so now I can say import transformers. Cool. All right, it worked. Okay, well, yeah, I will, that means I'll get to try playing with this cheaper instance, see if I can keep going further down and see if it works or if there's other issues. But I wanted to show you guys, now that we've looked at that, wanted to show you kind of what you do to update the code. And got a bunch of notes on that in this doc. Maybe since I've got this guy running, I'm just going to try running it. Let's see if we'll let it run in the background and then we can come back to it and see. Well, that's a little odd. 8x Tesla V100s. Oh no, here we go. It's running that right now. Okay. All right. So using multiple GPUs with transformers. Not too hard. They make it pretty easy. But there are just little subtleties to getting it right, I found. So for starters, so I asked about this last week, and Diogo had pointed out that Hugging Face uses this trainer paradigm that makes it's kind of their way of like simplifying the training process, and it's got parameters for easily leveraging multiple GPUs. So Nick and I tried this interface a while back. It's probably like 6 months ago now, just for a single GPU, not multi-GPU use. And we ran into issues with it, which has kind of been like our experience both with this trainer paradigm and then with the simple transformers library. Anytime someone tries to like simplify this process, it seems to create problems for us. So yeah, and then given that like all of our example code is currently written like more at the PyTorch level, I decided I'd stick with kind of the PyTorch code for now, and maybe we'll look at the trainer later on. And then also Diogo had shared, I had to kind of go back to the video and listen to it again to kind of hear a little more clearly what he was sharing. So I believe Diogo was saying that this trainer class actually came from this library called PyTorch Lightning. It's another popular library out there. And I think he was saying that they kind of like plagiarized it, copy-pasted it from that library. And it sounded like Diogo was saying that they even maybe confronted Hugging Face about it. So I'd be curious to hear more from him about like what happened there. Some fun drama. But yeah, so I'm sticking with the PyTorch implementation. And fortunately, the old, in the Hugging Face Transformers library, there's this examples code script for running the glue benchmark. And they've since updated it to use the trainer paradigm, but the original just used kind of PyTorch more directly. And I've got a copy of that older version. So I was able to just kind of poke through there and see how they implemented multi-GPU. So that was helpful. And you can kind of look through there and basically just check for these if tests. If args.number of GPUs is greater than 1, then do something special. And there's not too many of those, so it's fairly straightforward. The main thing, the real key is this torch.nn.dataParallel class. So that's a PyTorch class, and data parallel refers to data parallelism, which is where you leverage multiple GPUs by making a copy of your model and putting the same model on all of your GPUs. And then you take your training batch. So if you've got like 32 examples in your training batch and 4 GPUs, then you just chunk that training batch into 4 sets of 8 samples each, and each GPU works on a different subset of the training batch. So that's data parallelism. And then the contrast to that is model parallelism, where you actually divide the parameters of the model across your GPUs. So I had to learn a little bit about this data parallel class. There's a really short tutorial here that was helpful. Yeah, there's some subtlety to where you, like how you get the model onto the GPU. So I believe the way it works is that if you've got an 8 GPU server, you're supposed to put your model on device 0, and then the data parallel class will replicate it for you across the other ones. So I had to make some subtle modifications to the code to get that to work. All right, so yeah, so data parallel, when you make this call, model equals data parallel model, you're just wrapping it in this data parallel class. And yeah, when you call forward on the PyTorch model to do a forward pass, it handles the distribution of the inputs for you. Yeah, so there's a little documentation, PyTorch documentation for data parallel. I thought the introductory paragraph was kind of helpful, but then after that, it started to get a little overwhelming. A lot of like pitfalls that they warn you about that I'm like, oh man, I'm not sure what they're talking about there. But yeah, this is helpful, I think. In the forward pass, the module is replicated on each device, and each replica handles a portion of the input. And then during the backwards pass, gradients from each replica are summed into the original module. Yeah, and then that works. I think that makes sense because when you're training on a training batch and you've got multiple samples, you take the gradients from all of those samples and sum them together before making your updates. So yeah, so I think that makes sense that works, that you can just let the different GPUs compute those gradients and then just pool them back together, sum them up, and take their average. So yeah, and you can specify which GPUs you want to use. Right. One other change is this loss.mean. So when you're doing the backwards pass, you have to average the loss. Okay, so I'll show you guys my code. I took our like basic sentence classification example and got it working on a multi-GPU setup. And let's see, this looks really small, I think. Let me try to close the table of contents. Good, okay. Yeah, so this is that like being specific about the devices. So we used to have this line in here, torch.device CUDA. I changed it to CUDA:0 to specify that we want device 0 out of 4 or 8, whatever it is. Right. And then when we use the huggingface library to load our pre-trained model, after we've loaded the model, we apply the data parallel wrapper. And then this is another thing I had to figure out. So we used to use this line here, model.CUDA. And this either copies the model to like the default device or maybe to all of the devices, but things didn't work when I used this. So I had to specify model.toDevice instead. So yeah, that makes sure that it gets copied to device 0, which is what the data parallel wrapper wants. Okay. Yep, and then this is inside, zoom out just a little bit here. This is inside the training loop. So in the forward pass, it's unchanged really. I don't have to like split the batches across the GPUs. I'm still just taking a batch and running a forward pass. So this code is like totally unchanged from the single GPU case. The only difference is that the So it still returns this result dictionary that's got all of the outputs of the forward pass in it. And it's just a single dictionary. It doesn't return like one per GPU. And then the loss attribute is now a vector. It's got multiple elements in it instead of just being a single scalar. So you have to add a averaging step, loss.mean. And I think that might be it. Yeah, where's this at? Back at the top? Yeah, so pretty straightforward. They make it not too hard, which is great. Is there anything else I had in here that I wanted to share? Yes, okay. So yeah, one interesting thing that happened that I thought I'd see if you guys had any insight into. I ran it both on, so this is the training time for a single epic on Google Colab using a single P100. So it takes 50 seconds to train that one epic. And then over on Lambda Labs using the 8x V100 instance, the V100 is newer than the P100, so it should be faster if anything. It took 3.5 minutes. So it took more than 4x longer on the 8 GPU system. So it's not totally crazy because I know that when you divide something across multiple devices, there's this synchronization that has to happen. You've got to distribute stuff and then pull it back together. So I imagine that's where the loss of time is. But I'd be curious, like, if this doesn't work, then what's the missing ingredient? Is my batch size not large enough? Are the vectors not big enough? Where do you actually start to see benefit from training on multiple GPUs? And why might this have been slower? Yeah, and then I had this to do, but I think we fixed it. Let's go check that out. Let's see if it ran. No? It got stuck right here, it seems like. Because this is still the output from my last run. That's not new. Yeah, I'll have to play with that more later. Won't hold you guys here. Yeah, and this one's nice and cheap, so I think I can just leave it running for a little while here. Where is it at? It's this one? Yeah. So we've only spent 38 cents while we've been sitting here. That's good. Cool. So that's what I've got for this week. If you want to peek ahead, I've been reading through the paper, annotating it, putting some of my notes in here. But I'll plan to share more on that next week instead. So let's see. Why don't we just go? I'm going to switch over to this doc. And if you guys have any questions, we can cover them in here.